Okay, so this tech talk is called Fun with ZFS, and you will learn why it is fun sometime later. But first, you will learn who I am. So, as you see, I'm a software engineer here, and I'm working on rewriting an API server and some related stuff in Go, from some pretty terrible Python code to new, stupid, and very readable Go code.
You mean simple?
Stupid is simple. You know, it's keep it simple and stupid, right? Okay, so first some introduction, why I'm doing this talk. So how many of you have heard of ZFS? Oh, that's a lot. And how many of you have used ZFS?
How many of you used in production?
Yeah, so how many of you used it in production? Okay, so this talk isn't gonna fail. It's nice. Okay, so basically ZFS is usually used on some storage servers. It's used for storage. So, but I'm using it in a different way. I'm using it as a root file system on my laptop. So,
What's your operating system right now?
Linux. So, this laptop has Bajaryn Linux, and this one has Fanta Linux.
Okay.
So basically, Gentoo derivatives. And what I will show later is that this one also has OpenIndiana. So it's a different Unix. Okay, so this presentation will have basically what ZFS is and how you understand it, some features that I use day to day, also boot environments, which is a really nice feature, as you will see, and also a nice demo of having two completely different operating systems on the same partition. So ZFS was created at Sun with a lot of, with some aims, and the ones important for me are that data integrity is above all. So it protects the data from hardware, and it also protects it from the user. So protecting it from the hardware means that data is checksummed, and basically, if any piece of hardware fails, you'll at least know that it failed. And if you have redundancy configured, then you will also not lose your data. And protecting from the user is allowing to have snapshots and clones. So if you accidentally remove something or destroy a system, then you can just boot an older version of it, for example. And simplicity of administration. So you have only two commands to use, and one is for administering disks, and the other is for file systems. So the basic concept in ZFS is a pool, and it's based on disks. So see in a similar way to the LVM that you probably have on your systems if you use the default Ubuntu install option. Yes, the default Ubuntu install option has one partition and an LVM group on it, and some logical volumes on top of that. So ZFS is also similar in that you have a pool, and you can compose this pool out of multiple disks. So in this case, in my usage, I only use one disk. So this doesn't use this advantage of different RAID levels and different setups like that, or even mirroring, but it still makes ZFS useful. And on top of the pool, you can have these file systems or virtual block devices. So in LVM, you have only the latter. So LVM provides you with some virtual bytes, which you can use to create file systems on top of. So it emulates multiple partitions on top of one, but you still have to manage the size of those virtual devices and so on. So in ZFS, you have file systems in addition to that, which are managed by ZFS and share the same pool space. So one advantage is that the configuration of storage is stored on the pool. So in LVM or Btrfs, you would have an etc fstab file, which describes where to mount your file systems from the disk. And for example, if you attach your disk to a different port, then this configuration might suddenly break, and your system is not bootable anymore. So in ZFS, this configuration is stored inside the pool itself, and not in configuration files. So if you attach the disk to a different controller, the system will still pick up the pool and detect the disks. And this is achieved by having the pool properties, which I won't talk about until later, and dataset properties. So some of them are ones you could see in fstab, like access time, or whether things should be allowed to execute from this device. And there are other properties, like compression, and mount points or can mount. So you could also see mount point in fstab, and can mount, which is like the auto and no auto option in fstab. And you will see later how this is useful. So here we can use the datasets on my system. So here we have my root file system and some subfile systems and some others like home. So on the right you can see the mount point property of those file systems, and most of those aren't set explicitly. So if you set mount point equals home on the home dataset, then the sub datasets will also inherit that mount point. Yes, so here you can see an example of that. So we can create a file system and a child one, and see that compression is on by default on this pool. So then we can change the compression. For example, we want to have some storing compression for some huge text files, but we don't really want to read those. So we set gzip9, which is really slow. And we see that the child inherited this property. So the new files, the new data you write onto those file systems will be compressed with gzip9. And you can reset the compression to the default value. And then the inheritance comes directly from the pool root. And here you can see how you also inherit mount point properties. And in addition to this, you can use the can mount option. So it is on by default, but can be set to off so that trying to mount this dataset fails, or it can be set to no auto, which means it won't be mounted automatically, but when you run ZFS mount dataset name, it will mount it. And also can mount equals off can be used to have some file systems, like you could set can mount equals off on CLTalk, and then you will have CLTalk, you will have MNTtalk empty and MNTtalk first mounted from CLTalk first. So this can be useful for things like VarDB Postgres, for example. So you don't want to have a VarDB volume, but you want to have Postgres on a separate file system so that you could manage snapshots and compression settings or block size separately. Also, ZFS is called a copy and write system, so almost nothing is ever overwritten on the pool. So when some data is changed, instead of overwriting the existing block in place, it creates a new block and then creates a new path from the tree root to this block. So if you change a file, then a new copy of the directory containing the file will be created, and the reference to the directory from the root will change. So only the root pointer is overwritten, and there are also some backups of that root pointer, about 200 or something. So using those backups, you could recover a broken file system if it's really broken. So when you fail to import a pool, which didn't happen to me, but you could choose an older version of the root pointer. And as I mentioned, data integrity above all is the main rule in ZFS. So, and implementation of that is that user data also has a checksum. So in a regular file system like X4, you would have checksums for the metadata. So if part of a directory gets corrupted, then the FSCK will detect that and, for example, remove that directory or remove those files. But in ZFS, also if a bit flips in your user data, like the file contents, then you will notice. So when data is read and some IO error happens, like the disk says that it failed to recover the data from medium, or if ZFS reads the data, computes the checksum, and the checksum does not match the checksum it read from disk from another place, then it tries to find another copy of that. So if you have a mirror, if your pool has a mirror or a RAID group, then it would probably find another copy and then overwrite the original copy with the working version. And ZFS knows which copy is good because of the checksums. And if no working copy is found, then it will return an IO error. So even if it managed to read some data from the disk, but the data isn't good, then it will return an IO error, and you will notice this and think about replacing your disks or something like that. And also, even if it does find good data, then still the checksum error counter in the pool status is increased. So in a properly configured system, like in production, you would get an email about that, for example. Oh, and some anecdote from my life here, that I had an SSD that was pretty broken because it returned bad data and then reallocated the sectors to some fresh ones. But it should really reallocate them before the data becomes unreadable. But it did after and did not notify the system. So ZFS detected that, and thankfully it was not very important data. So then I backed up everything, rewrote it with the copies equals to property, and then for every error it had a good copy. So I managed to use this SSD for one more half year, even if it was somewhat slower on writes. It's pretty high write latency sometimes. So another feature I use daily is snapshots. So you can think of a snapshot as a read-only copy of a dataset, but it's not really a copy, because due to the copy and write nature, you can just take an old pointer and just remember it. So you don't have to copy anything. So basically, it initially takes no space, but if you remove some files that are held by the snapshot, then it will show up as taking some space. Or if you change those too. And there is a ZFS rollback command, which is useful in case of accidents, for example. And those snapshots are also mounted at the dataset mount point, .zfs snapshot, and the snapshot name. So in case you want to look at some old files, you can do that easily without running any mount commands.
By default, it's also hidden directory.
Yeah, it's hidden, but those are still auto-mounted. And there are options to enable, to make it visible, or to disable .zfs, for example, in some context where it's insecure to allow that. And we also have a ZFS diff command, which can be used to show differences between two snapshots, or between the snapshot and the current version. So it could be, sometimes it's faster than a regular diff recursive. And there are also clones. So a clone is a dataset started from a snapshot. It could be read-write, like by default, but you could also make it read-only for some reason. And since you can only revert to the latest, you can only roll back to the latest snapshot, then you cannot roll back to some earlier state. So when you want that, you can make a clone from that, and then swap the current version with the clone. So now you have the old state, and you will also have your latest state in another dataset. But there are some limitations to this, as you cannot swap file systems without unmounting them. So if something is mounted and a program is reading from it, then you cannot swap them. So this is a problem, for example, with root file systems, as something is always using a root file system, like init. So you will see a possible solution to that. So boot environments, that's another topic. And basically, the main question is, what is a boot environment? Because it's such a strange name and nobody gets it. So, as Oracle describes it, it is an OS installation, so and this is an instance of an operating system with some software, but it does not contain the user data. And you can also think about it that it's just a data set, like pool, root, fun2. And this data set can also have some sub-data sets, like user or var or var log, if you want to keep your logs separate for your system. So this is how these datasets look on this laptop. So I have the current Subway version and a slightly older one, like from a week ago. So you see that the newest one takes almost 100 gigs, and user of it takes about 50 gigs. This is also due to snapshots, because there's a lot of those, and they hold old copies of software and other things. And the older one takes only 34 megs, as that is the difference. And we'll also see that the home and also the bootloader files are separate. So whichever system you boot, you will still get the same home directory. So you would think that it would be easy to manage those boot environments by ZFS commands, but it turns out it wasn't. And I did try. I had some scripts to manage upgrading my systems, so making clones of all of this boot environment dataset as these sub-datasets, and also destroying them and mounting them and chrooging into them. But that turned out to be error-prone, and this script sometimes failed me. So there is a solution to that, which is a shameless plug. because it's by me and Alexander Misterich, and it is basically a port of Illumos B atom in the core. So that utility is used to manage boot environments, and you can do most things in one command instead of some short loop with regular ZFS tools. So this could be used, for example, to operate your system in a clone. So you don't have to break your running system, you don't have to break your running system, and can do the upgrade peacefully while you do something useful. And then you can reboot into the new version, because you can choose a boot environment when you start the computer. You can also, instead you could create a backup boot environment. So you run B atom create, then you run your upgrade, and if it's bad, then you reboot into the old version. And this could be also used to transfer boot environments between systems, as there is a ZFS send and ZFS receive command, which is used to serialize a dataset or volume into some bytes, and those bytes can be sent over the network. So B atom also contains a command to create a boot environment on another pool. So you could have, for example, external HDD, or a pool you have on some remote storage, like I have on NFS. And you could send over some of your root datasets to this other storage and then delete them if you don't have much space. So this project basically consists of three things. So B atom, which is a port of C code from Illumos, and B emerge, which was called like this because the Gentoo package manager CLI is called emerge. So it was made to make, the original idea was to make emerge have a boot environment option. So you could say upgrade the system in environment B, or you could say install this package in environment B. Or there are other options you will see later.
I've got a question. Did you manage to port the full BADM from the Illumios?
Yes.
Oh, nice.
It works. You will see.
Oh, yes.
Is this your thesis?
Yes, this is my thesis. Started late last year and ended this year. And also it became public today, so you can look at it and install it. If you have Gentoo, then it's just a couple of comments to do it. Gentoo on ZFS. And it also has some boot menu script for grub. So there are some other scripts like this that already have this kind of functionality, that list boot environments and add them to the menu. But this one differs that it was made as a grub to fork, and I tried to integrate it with the default Linux boot scripts. So hopefully I can upstream it, and then everyone will have boot environments in their boot menus, in whichever way they choose to manage their boot environment. So this is how the boot menu looks on our test system. So the system we actually used to submit this thesis, we submitted it as a VM. So yeah, basically here you can choose any boot environment, any Linux boot environment. So this is B atom. It has some regular commands like ZFS, but it also manages those sub-datasets. So these are, like, you could create a boot environment, create a snapshot of a boot environment, and create a boot environment from a chosen boot environment or snapshot. So it either creates a snapshot and clones it, or it just takes this snapshot and creates a clone from it. So there is rollback, there is destroy for boot environments and snapshots, rename, and there is also list, like ZFS list. So this output is a lot more compact by default, but there are options to show the datasets and the snapshots that are contained in the boot environment. There's also the active field, which is N means it is active now, and R means it will be active on reboot. So those could be set on different boot environments. So you have a boot bajaryn activate command. So you give it another boot environment, and then on reboot you have that as the default in your grub menu. But you can still choose any of those and boot it. And there is an important part is a mount command. So you can mount any boot environment and then change some stuff in it. So you could clone your root environment, and then you could upgrade your system in that clone. But mount is not enough, as you would need to chroot into it, because in Linux most commands don't have an option for an alternate root. In Illumos they do, but also not all of them. So here you have a bmerge command. So originally it was an interface for emerge, but now it can run any command in a given boot environment. So basically, you could give it a command, you could give it an option of a boot environment, an option to create a boot environment where -e means which boot environment it should be created from, and you could also specify both. So if you don't specify the boot environment but specify the source, then it will just take the last number. So if you have fun2 8, then the next one will be fun2 9. Or if you already have fun2 9, then it will be fun2 10. And basically this command uses the libbe, so the library that bajaryn is based on, because it's really a small piece of C code, and libbe is really the piece of software that manages boot environments and calls the bootloader to update its boot menu. So I use this command to operate my system. So it's pretty long. It looks a bit shorter because I have some aliases, like you see here, zshell interactive, so that it would expand the aliases. But it's basically update the repositories, upgrade, then update the Gentoo repositories, and install the new ZFS kernel modules, as you need those. You need to rebuild kernel modules when you upgrade your kernel. And then we use and bajaryn activate. So if this upgrade fails, then the boot environment will just lie around and not be the default. So you won't shoot yourself in the foot, at least not in this way. So there are a lot of other solutions to this problem. So there are a lot of bajaryn scripts. Well, at least 3. So there are scripts using in bash or maybe kshell, but those are they're older than my part, and a lot of people use those. But I can show you why this bajaryn C code is better. So basically it's pretty old. It has some bugs, but at least a lot of the bugs have been eliminated by daily usage on Open Solaris and other Illumos distributions. It is also available in FreeBSD, but I think it's based on a different code base. And this solution is also integrated. So if you use Gentoo, then you take our overlay, which is a Gentoo word for a custom package repository, and you just install the packages. And well, after some merge requests in this project are merged, then you have 0 configuration of this. So if you have your root on ZFS and you have it in those datasets like pool/root something, then it will just work. Yeah, and you have grub too, because that's the bootloader we support. We could support others if they're good. I haven't tried them. There is ZFS support in U-boot, and there is ZFS support in UEFI. So those could be good, but I haven't tried those. And there's some demo, and it's going to be a really live demo. So I could really break my system, but I hope that Bajaryn saves me. Yesterday, I tried to make this demo to prepare the demo, and I really broke my system. So Bajaryn did save me. I could reboot into an older version, and then roll it back to the previous one. So basically, the idea was to remove my /bin directory. So I couldn't ls, I couldn't mount, so I couldn't even go to .zfs snapshot. So basically, I didn't even know if the snapshot I made contained the binaries. So I didn't know if I removed them before the snapshot or after the snapshot. But I could reboot into the old version, roll back, and then reboot back. So let's see what I can do. Okay, looks like a terminal. Does everyone see the text? Do you see the text?
Yeah.
Okay. So here we're gonna go to. Yep, it works. So let's see. Here we're gonna do a slightly less dangerous demo. We're just gonna remove the mount command and maybe ls, because who needs ls anyway? We have zshell. Oh, it was close. Okay, I wanted to do this in a different boot environment, but I made it on the live system. But it's no problem, it's just mounted ls, right? So okay, so we can have Bajaryn list, and it's pretty terrible. And here we have these are the snapshots of my current boot environment. So there's a lot of those, but they aren't really all snapshots of this one. But because it's the active clone, it has all of the snapshots of the previous clones linked to it. So probably only a couple of the last ones were created on it. So actually Bajaryn list is not good at this thing because it sorts the snapshots in some strange way, not by date, but by name. So we will use ZFS list here, and it's not too bad at this. So all the snapshots are recursive, so they're the same in user and the root dataset. So let's take the last one. Oh, I have a proper mouse. Okay, so it's working. So, that was pretty short. Okay, so this demo is done. And there's the next part. with an even more fun demo. So basically, we have ZFS comes from Solaris and Illumos, so from Unix systems, and it was also ported to FreeBSD, and only after that to Linux. And it also has been ported to OS X, so you could install the kernel module on your Mac and connect some hard drives with ZFS. But you cannot boot Mac from ZFS. However, it is the standard root file system on FreeBSD and Illumos distributions. It is also being ported to Windows, so this could be really fun. And probably it won't still be able to boot from it, but maybe it could boot from a ZVol, which is the virtual block device. So if you could make a virtual hard drive driver for Windows, for ZVols on ZFS, then this would be really awesome. And then it will be pretty hard to break your Windows system, as you could just roll back your ZVol, which is, well, it would probably give you a blue screen, right? Because you don't just suddenly change half of your disk bytes under your system and expect stuff to work. But you could at least reboot it to an older version, or at least say like batum activate old version. So this would be cool. But currently it's a work in progress driver which you could install and it would crash your system sometimes. So I'm gonna try it soon. After I install Linux on this one.
Just Windows things.
Okay, so basically the idea is that here we have Illumos and the OpenID distribution, and I have installed it on the same pool with the Phantom system. So this wasn't easy, and initially it was, well, there's some description of that. So initially it was pretty hard, as most Unix systems are made in a way that you give it a whole disk and then it installs itself on that. So I don't really have 2 disks on that laptop, even though I could. And basically with ZFS, it shouldn't be really necessary to give a whole disk, as you can just have a different file system on the pool. So the setup of this installation is that there is some hacks to make Illumos happy, like the reserved partition after the pool, so that it doesn't confuse the partition and the whole disk device. And we also have to make the pool root dataset mountable. So usually you don't really want to use a pool root dataset for anything, as if you don't create any snapshots and then just write to the root pool dataset, then it will use some space. You could remove the data, but it will still be changed. And you cannot rename the root dataset to anything else under itself. So basically, usually you don't use it, but Illumos uses this root dataset to have the boot menu, because that seemed like a good idea, and it's not so bad. So in the Linux implementation, in our Linux implementation of boot environments, we have those boot manager files in the grub dataset, or really anywhere. It just needs to be a dataset mounted at /boot.grub. So we have 2 different boot environments, so this is pretty good. And have some datasets for Linux and datasets for OpenIndiana. And it's good that these ones don't conflict, so we have a different default home path for OpenIndiana and for Linux. I could really have one home directory for both, which would be fun, but I didn't try that yet. There is also the dump device, so that's the ZVol that gets the crash dumps if Illumos crashes or kernel panics. So in Linux, there are some custom solutions for that, like Red Hat's, or like my custom initram file system. So when your kernel crashes, then the kernel already has a different kernel image prepared in memory, and it just kexes into that. So it's the same as if you would boot that image from memory. And then you could use that image to save your whole RAM on disk, and then use some debugger to look at some backtraces. And it was pretty useful. So I've been using ZFS en route since about 2015, and initially it wasn't that stable on Linux. So having those crash dumps was pretty convenient. Right now it doesn't crash. Haven't seen the kernel panic in a while. Okay, so
I've got one question, because you're using Linux and OpenIndiana, and they have a different ZFS versions. Did you have any problems with the compatibility between the versions?
okay, right now I haven't had that. Well, I did. So basically, both Linux and OpenIndiana use code derived from OpenZFS project.
Okay.
So basically, the code is mostly the same, but it could be a bit. Basically, different implementations of ZFS have different feature flags. So
Yeah.
of OpenZFS. So basically, I just kept using some common feature flags to both versions.
Okay.
So like ZFS on Linux version 0.7. So using all the feature flags for that version is good enough.
Okay.
And OpenIndiana has some feature flag called multi-VDEF crash dump, which is for some crash dumps on this dump device. And there used to be problems on Linux with that, but now they patched that. So there is some stub code so that it doesn't crash when it sees those dump devices without checksums. And there was this compatibility problem with that I had to have this reserved partition after the root. So that was because a fix was made in Linux, but it is not ported to Illumos. I think it's not ported even now. So it can, if the pool ends at the end, close to the end of the disk, then it could confuse the root, confuse the disk, the whole disk, and the partition. So then it would have problems importing it because it would try to read the labels in the beginning of the disk, but it won't have those. So one workaround was to just, RM those dev hard disk devices. So remove the whole disk device and then import it as a partition. That was pretty annoying, but so just remember to have a reserved partition at the end if you want to boot Illumos, or if you want to import pools from Illumos without some hassle. Okay, so here is how I installed it. So the recent versions of OpenIndiana, I think since last year, they have an option to install to a new boot environment on an existing pool. So this is really good. So basically, you boot the live drive, then do some magic with pools. So you have to import it because we have this thing called host id on the pool. So if one system has imported the pool and, for example, boots from it or uses it as data, then the host ID generated in some crazy way is recorded on the pool. So if you try to import it from another system, then it will tell you that no, it might be on use on another system. So this was made originally to prevent problems with multipath setups. So like you could have a disk connected to two systems at the same time for some failover, like when one system dies.
Multiple controllers.
Yeah. So you could also have a disk connected to multiple controllers. So if one controller dies, then you're still not so broken. So that was to prevent the problem for one system writing to the disk and then another one corrupting its data. So that would be terrible. So there is this hosted. Now on Linux there is a better setup for that. So there is some reserved area on the pool where a system periodically writes to. So if another system before importing the pool, it would look at that area, and if it sees any changes on it, then it will say that that pool is really in use by another system. So this solution is really useful in class environments, but that previous one is a bit worse, and it's causing me trouble with this stuff also. You will see how. So yeah, here we have these terrible hacks I have to do, and I have to do every time I reboot into a different OS. So one thing is that you have to force import the pool on Linux when you reboot from OpenIndiana, as the host ID computation is different on those two systems, which is also pretty bad, because it should be only based on the hardware of the system. And you have to do the same when rebooting into OpenIndiana, but there's a problem, as I don't know of any initial run file system thing that can be used to just force import the pool before the actual booting happens. So at least on this demo, I will have to reboot into a live USB and do that manually. So this will take some time, a couple of minutes. And there's another thing that you have to set the bootfs property. And yeah, here you see pool properties, which are more like properties of the hardware. So a pool could have a property of a shift, so it's an alignment shift. So you could have, so that ZFS uses 4K blocks on SSDs and 512 byte blocks on some spinning rust, on all spinning rust. And yeah, so you have a bootfs property, and it usually, on Linux, people usually think it means that it's the system, it's the default root file system. So some Linux setups are made in a way that it just looks at the bootfs property and boots from that. So you could emulate BR activate by changing that value. But in Illumos, this is made in a way that the bootfs means where to take the bootloader files. So even in our badd import, we still set the bootfs. So that could be a problem, as this could be a problem as a bootfs is set to a Linux system, and Illumos expects to read its bootloader files from that. And obviously it fails, and then you have to write your boot command manually in the command line, which is also not so bad. It provides you with an example, so you can type that. Okay, and now the most fun thing in here. So here I have a different laptop, and the reason for this is that one thing is that this is my work laptop, so I don't want to break it, right? Not that badly. Don't really want to have unbootable Linux partition when an unbootable Linux system when you have to do some real work, right? So, and another reason is that older OpenIndiana distributions really don't work well with new Intel hardware. So this one has old Intel hardware, it's 2009, and it also has an NVIDIA card. So NVIDIA has drivers for different Unix systems, Linux and Windows, and well, it just works. The proprietary ones. Okay, so now sorry, I have to disconnect this one first. Okay, so let's start it. So this laptop is also good that it shows the boot screen on the external screen. So, well, if you wait for it to detect the resolution, then it works. So here I have some boot environments, a lot of them, because I experiment a lot, and also test different releases of that B add-on port. So this one is the default one. I just move the pointer here to make it stop the automatic booting until the screen refreshes. So first let's boot this one. This will take a while, as well my setup is somewhat bad and it takes a minute or two to import the pool for some strange reason. As
1 minute.
hmm?
1 minute.
Something like that.
Okay.
Because
Yeah. On SSD or
yes, this system is an SSD, so
Okay.
this is really strange. Maybe it's waiting for some UDEV events, because this could be true as this one doesn't run system D, so it's really isn't well integrated with UDEV. So here you see some, okay, you don't see the error anymore, but that error is from my hacky code, which I just hacked on the init.rs code so that it would mount my sub-datasets of the boot environment, as the boot environment uses the can mount equals no auto option, so you could have different datasets with the same mount point, or the root. So basically, the rootfs, the init.rs has to work around that and mount the datasets, even though those aren't, even though they have no auto. And Illumos does the same thing. Okay, you can see KDE Plasma and i3 here.
In general, it works.
Yeah, this is Linux and it works, like usual. And you see this wallpaper as, yeah, and it's not even stretched more than necessary, so it's pretty good, as the colors suck.
That's good.
That's
Okay, so here you have the same old terminal, the KDE terminal, and I'll show you some command outputs, because why not? So this one is a bit bigger, as I did a lot more stuff here. So also some boot environments. This one also has a special boot pool, a separate one, because I wanted to experiment on this system more. So I wanted to be able to have a pool with all the latest features, but still boot Linux on it. So I had a separate boot pool with an old version, so the grub could always access it, because grub support for feature flags lags a lot from upstream. But in this case, I have no kernels on this one. Well, I have kernels here, but this thing is not used anymore. So this boot pool only contains grub files. And the kernels are inside the boot environment. So now you don't really need to keep around a couple of kernels because you can always just have a different boot environment with a different kernel. But after all the merge requests are merged, our grab tool will also list all the kernels inside any boot environment. Okay, so there are some things I mentioned in setup. There's also FreeBSD, more precisely Gentoo FreeBSD, and it isn't bootable here, but I booted it in a VM from NFS, so I can still have stuff on one ZFS pool, but I started a VM and it has its root through NFS from this system. And that worked also thanks to having a property of NFS, of share NFS. So basically you can specify that this should be shared over NFS and all the sub-data sets are shared automatically. So this is very convenient. And you don't have to change any NFS config files. Okay, so now I'm gonna reboot into OpenIndiana and continue with the demo. Oh, and I can also show the other list because why not? And also uname. So you see it's Linux 4.1. And you can also see some OpenIndiana boot environments in this list. Okay, now we're gonna reboot. This will also take like a minute to help the system. It also should be faster on this SSD. And then we'll boot the live USB to import the pool on Illumos so that the host ID matches the one on the installed system. And it's also gonna take a while because the pen drive is slow. Yes, and this OpenIndiana release, this OpenIndiana releases are called Hipster, as before this they used to have some proper releases, and the rolling release was called Hipster. Now they also do have releases, but they're still called OpenIndiana Hipster. So let's wait for it to load its kernels.
Witaut. In the meantime, when you were showing the disk usage statistics, right? We had 3 columns. It was something like available in the middle, and then used and referred. What's the difference between used and referred?
The reference to the original data.
Yeah, so the question was that we have, when we show ZFS list, we have more than just the used column, more than the used and available column, but also the refer column. So basically, the refer means just how much data this particular dataset refers to. So you could have a dataset. You could create 100 gigs of files, make a snapshot, then remove all of those. So you will have dataset used 100 refer 0, about 0. Then you will have dataset at snapshot used 100 refer 100, and you will have, well, if you make another snapshot, then you will have it have used 0 refer 0.
What's the difference between the datasets? So, for example, you have a line with 1 column and 5 columns and different ones.
Okay, so OpenIndiana is booted. Almost, I guess. No, it is. It's just extended the desktop, so this desktop is really wide. And you can also have internet here. So it has those proprietary blobs for the Wi-Fi, and it also works with the Ethernet, but we don't need internet here. So we could also install another OpenIndiana boot environment from here, like I did today. So yeah, what we really want is to run a terminal and import the pool. So no, this is not a good idea. So yeah, and also these new OpenIndiana releases are good because they have new X server with all of the keyboard layouts. So I can even use it. So here this means that the pool should be imported, F means force, and N means don't mount datasets, because we don't really want to waste time on that. Okay, and now we can just boot OpenIndiana from the pool without any live media.
I've got a question. Did you make any modifications to the default caching layer or something like arc size, for example?
No, I didn't really have to. On this system it can be a problem, but not because ZFS eats too much RAM, but because it can't eat enough RAM.
Yeah,
So
that's true.
the thing is that ZFS has its own cache, and it's not really well integrated with Linux own cache, not yet. But it works pretty good on 16 gigs of RAM. But it's not that good on 3 gigs of RAM. Okay, let's start it. So we put this one, and it works. The way it works is that it chain loads the Illumos loader. We can also select the boot environment here. This also works, but we're just going to put the latest one. So the way it works is that it loads the Illumos loader from the pool's reserved area, and the reason it has to do that is while grab2 does have support for booting Solaris, it seems broken in the latest release. Well, in the latest beta release or whatever it is. So I have to chain load Illumos loader, but it works. I will see how I can manage that with FreeBSD. Maybe I will chain load the file if it can be done. And also, the thing is that Illumos loader also can put Linux, so doing it the other way around, just putting everything with Illumos loader could work. And people say that it might have newer support for ZFS feature flags, but it might not. As I also heard that the implementation of reading the pool is also based on drops code. Okay, so it booted and a bit quicker than from the USB. And it also connects, yeah, it even remembers the Wi-Fi. And it's not using Network Manager, they have their own thing called Network Automagic. And it somehow works, has some advanced configuration, which I didn't try, but should be good. So we have this same list here, and we could also see some other stuff. So we see that the root is mounted from this boot environment. Yeah, and Illumos lists the mount points in some reverse order, so we see root on OpenIndiana 1804. And here we see SunOS 5.11, which is Illumos, or I think OpenSolaris has the same version, maybe. And now we can reboot back into Linux. So as you will see in a short while, in Linux it's a bit easier to force import the pool as we have the initial run file system. So basically, to put something as complex as ZFS, right now you do need an initial run file system. So basically the kernel boots from a RAM disk. Well, it takes, the bootloader takes an archive and then unpacks it into the memory. And then the kernel boots from the RAM disk. So it has some basic files, some basic kernel modules, and then yeah, that's their goal. So, and then it uses those kernel, loads those kernel modules, and then it has enough drivers to actually boot from ZFS. So it changes the root into ZFS, and that works. So let's put this one. Now it's not going to work as smoothly, but this is not a problem, as this initial run file system is not that stupid. Well, it's stupid enough, yeah. So basically, there are other initial run file systems like Dracat, which comes from Red Hat and CentOS and Fedora. So that one could be configured to force import the pool and also to export the pool when rebooting. But Illumos would still not boot on an exported pool. It needs to be imported on this host ID. Yeah, so here we have an error that it failed to import the pool and then failed to see the file system as the pool is not imported. So what we're going to do is we're enter RSQ shell and then force import it and continue putting. And again, this takes a while for some strange reason. And you can also see those nice two penguins because there are two cores on the CPU. So while we do this, I can also mention that ZFS is not everything is good in ZFS. So one bad thing is that you can't shrink the partition. So you can only enlarge it, but once you enlarge the pool, you can shrink it. So this is bad when you want to dual boot with Windows, for example. But with powerful enough hardware, you could use a VM. But I'm gonna try dual booting with Windows on this newer laptop. So it's booted, and I think it's done here. So back to the presentation. There's not really much left, just a couple of slides. Yeah, so here we have Windows on this one, and it's not so good that it's Windows, but I can run Emacs on it. So basically the environment is mostly the same. But yeah, exactly. Emacs is an operating system. So yeah, Emacs on Windows. So Windows has this package manager called Chocolatey, and it has most of the software you want, even YouTube DL. So I could just install things and upgrade things too, which is better than anything I've seen on Windows before.
Yeah.
Yeah, so this talk was inspired by another talk. So that talk was about interesting things you could do with ZFS, with some examples of breaking the system, with some ARM with spaces. And also thanks to these two people, and probably some more people from Open Indiana for helping me with my strange problems. As I come into their channel and then say, oh hello, I can't boot, and then show them some comments where I import a pool with an alternative route to MNT Gentoo, and they say, what, you have Gentoo? So why are you coming to our channel? And I'm saying that it's just a mount point. And this pool also contains Gentoo. So this started like a year or even 2 years ago, and now I have a working version. Also thanks to this second guy who implemented Install into a boot environment in the installer. And you can also look at this presentation if you really want to. So this one is open since today, and you can run it if you have Go. You can just run.
You just have to compile it.
Yeah, but it compiles pretty quickly. You just run one command to install the presenter, run present, and yeah, you just open it. It runs the server, so you just run it. Thanks, that's all.